Next example here, f of x is defined as x cubed plus 2x, and we're asked to find the derivative, or f prime. So again, we use the definition of the derivative. Limit as h approaches 0. We have x plus h cubed plus 2 times x plus h minus x cubed plus 2x all over h, and the limit of that is as h approaches 0. So we have it's a little bit more complicated here. We have to expand this binomial cubed. So as we do that, we're going to get x cubed plus 3x squared h plus 3x h squared plus h cubed. Here I'm distributing the 2x plus 2h, and here I distributed the negative sign, so negative x cubed minus 2x. And you can see here again, many of these terms subtract out, so I have x cubed minus x cubed, 2x minus 2x, and all the terms that are left have an h that can be factored out, and then those h's will cancel out. I'm left with this expression, and again here now I'm at this point where I can just evaluate this limit by direct substitution. Both of these terms are multiplied by 0, so they go away. I just have 3x squared plus 2. That's my derivative. All right. The last alternative form of the derivative, if we're looking for the derivative at a specific point C, so the derivative of f prime of c, we can use some generic point f of x and the x value x compared to that specific point c f of c, and we can take the limit of that as x approaches c. Here again you can see that if x was equal to c, we would get a 0 over 0, which would be an indeterminate form, so we're applying that limit rather than just trying to use direct substitution. Alright, so differentiability and continuity are very closely related, but they're not the same thing. If f is differentiable at c, then f must be continuous. However, just because a function is continuous does not mean that it's necessarily differentiable. So there are a few things that can destroy differentiability. A discontinuity is one of them. So if we have a discontinuous function at a certain point, then that function is not differentiable at that point. If we have vertical tangent lines, that destroys differentiability. Or if we have sharp turns, that'll destroy differentiability as well. Right? So continuity does not necessarily imply differentiability. It could be a function could be continuous and not differentiable. And here's a good example of a sharp turn. We have a function. This function would not be differentiable right at that point there. Right? If you have discontinuity, then that definitely does mean that your function is not differentiable.